In this chapter, we'll be studying two different phenomena of light, reflection and refraction. So let's start from light. What is light? It is a form of energy. It enables us to see objects. It produces a sensation of vision in us. We can see different objects around us because of light. It travels in a straight line. Light always travels in a straight line, and this property of light is called as rectilinear propagation of light. Have you read about? No? Rectilinear propagation of light. Kabhi nahi pada? It was in class 6. And there was an activity based on it that where we had a candle and a pipe, and we see the candle flame through that pipe. When we bend that pipe, then we do not see the flame of the candle because light travels in a straight line. And next we have, it is a type of electromagnetic radiation. It does not require any material medium for its propagation. So it does not require material medium means it can travel in vacuum. Light can also travel in space. It can also travel in vacuum. It does not require material medium. It doesn't mean that it cannot travel through a medium. Light can travel through medium as well. Light can travel through water. We can see through water. We can see through glass. Right? So light can travel through a medium, but it does not require a medium. Okay. Next, we have velocity of light in vacuum is 3 into 10 raised to the power 8 meter per second. So in 1 second, light covers a distance of 3 into 10 raised to the power 8. Next, we have wavelength of visible light lies between 4 into 10 to the power minus 7 meters to 7 into 10 to the power minus 7 meters. This is the wavelength of visible light. So there are three components of sun rays. One is ultraviolet rays, other is infrared rays, and third is visible light. Ultraviolet rays and infrared rays are called as rays. On the other hand, we do not call visible light as visible rays. So what is the difference between a ray and a light?
They travel in a particular direction in straight line.
See, visible light is the white light and it also travels in a straight line. Doesn't mean that a ray travels in a straight line. It means that because do you see ultraviolet rays coming out of the sun or infrared rays coming out of the sun? No. We cannot differentiate. This one is the ultraviolet ray and it is coming out of the sun, and this is the infrared one and this is coming out of the sun. We only see the white light coming out of the sun, which is visible to our eye. Because we only see the white light, and the white light is the only thing which is visible to us, and therefore it is called as light, not the ray. On the other hand, ultraviolet rays and infrared rays, they are called as rays because they cannot be seen by naked. We cannot see ultraviolet rays and infrared rays. So have you read about ultraviolet rays and infrared rays in your previous classes? What have you read?
That the rays can't be seen by naked eyes.
Okay. And ultraviolet rays and ozone layer, is there any relation between these two? In our atmosphere, in the stratosphere, there is ozone layer present. So is there any relation between the ultraviolet rays and the ozone layer which you might have read in your previous classes?
The rays, then
Are ultraviolet rays harmful to us? They are. They can cause skin cancer. So ultraviolet rays are harmful. They can cause skin cancer, and they're trapped by the ozone layer, which is present in the stratosphere of it.
they are present in sunlight.
Yes, they are present in sunlight, but when they reach the atmosphere of Earth, so there is stratosphere. In the atmosphere, the second layer of the atmosphere is stratosphere. Lowermost is the troposphere, and then we have stratosphere. And in the stratosphere, ozone layer is present. It is about 50 kilometers above the Earth's surface. And that ozone layer traps the harmful ultraviolet radiations of the sun. And because they can cause skin cancer to us, so this way ozone layer prevents us. And infrared rays, because of infrared rays, there is heating effect in sun. We feel the warmth of the sun. That's because of infrared rays. Okay. And the wavelength of visible light. Wavelength means length of the wave of visible light lies between 4,000 angstrom to 7,000 angstrom, we can say. Angstrom is another unit of length. As we have meter, centimeter, millimeter, kilometer, in the same way we have angstrom. It is the smaller unit of measuring length, and 1 angstrom is 10 to the power minus 10 meters. Okay, we'll be studying about this later. So object and image. So what is the difference between an object and an image?
Object, we can say.
Mhm. If this is an object, you can see this object. How do you see this object?
Light,
When light falls on this, it reflects it.
like the moon.
It reflects it, so it is an object. Okay. So anything which gives out light rays is called an object. And the image of this object is formed in the eye, retina of our eye, right? And when image is formed in the retina of our eye, that message goes to the brain, and brain says that it is a remote. It is an AC remote, right? Yes. So where is what is image? An image is formed when light rays coming from an object. So these light rays are coming from an object, from this object, and they are reaching our eye, meeting at a point, the point where the rays are meeting. There, the image of this remote will be of, or this object will be formed.
So can we say the moon is an object?
Yes.
Because sunlight falls.
It reflects the light of sun. And we see the moon because the image of moon forms on the retina of our eye. Retina is like a screen. You have seen the video of candle flame activity, right? So in candle flame activity, we place a paper to get the real and inverted image of the candle flame. In the same way, in our eye, there is a screen where the image is formed. On cinema hall also, when we go to watch a movie, then we see the screen in front of us. When projector projects the light on it, then we see the movie.
Reflection.
Yes, we'll study about this later. So this is the difference between object and image. Next, we have types of images. So there are two types of images, right?
Virtual and
Yes, virtual and real.
real.
So we have two different types of images, real image and virtual image. Uh, the video that I had shown you just now was of a candle flame. And the image of candle flame was formed on the paper. Was the image erect or upside down?
Right.
It was upside down. Candle flame was like this,
Yeah.
and when we had seen the image on the paper, it was upside down. Ulti. Anything. So real images are always inverted, and we always need a screen to see a real image.
Yes.
That image is virtual image because we do not need a screen to see our image in the mirror, right? It is formed in the mirror, so we do not need a screen for it. That image is virtual image. But where we need the screen is the real image. For example, in cinema hall, there is a screen in front of us. When we go to cinema hall, we have a screen there. So because the image is formed on the screen, images that we see, they are formed on the screen, therefore they are real images. But how do we see the actors and everything there? We do not see things upside down there, right? We see the images erect. But no, real images are inverted. They are not erect. We project in such a way that we see the erect image. Okay?
Yes.
So real image is inverted. On the other hand, virtual image is erect. Second, real image is formed when rays actually meet at a point. You'll understand this particular difference later when we'll do the ray diagrams. So when rays actually meet at a point, then real images are formed. And virtual images are formed when rays appear to meet at a point. हमें लगता है कि rays मिल रही हैं, but they are not actually meeting at that point. Real images can be obtained on a screen. On the other hand, virtual images cannot be obtained on a screen. For real images, we always need a screen to see them. But for virtual images, we do not need a screen. Real image is, for example, the image formed on cinema hall is real. On the other hand, image formed on a plain mirror. On a dressing table, the image is virtual, not real. We do not see the upside down image. We see the virtual and direct image, right? Now you have to identify the image as real or virtual. You'll give the answer now. Image is inverted. Is it real or virtual? Real images are inverted. So it's a real image. It is upside down. Image formed by the actual intersection of rays of light.
Virtual.
Actual intersection is real. Apparent intersection is virtual. When rays actually meet at a point, then it is real. But when rays appear to meet at a point, then it is virtual. Image is direct. Yes, what?
Real.
Image is direct. It is virtual.
Virtual.
Image cannot be received on a screen.
Image on screen.
Image which cannot be obtained on a screen.
Virtual.
Yes. Image is formed on screen.
Real.
Real. Image formed by the apparent intersection of rays of light. Apparent means where rays appear to meet. They are not actually meeting, but they
Virtual.
appear to meet. Virtual.
Example mirror.
Yes. Next, we have the difference between reflection and refraction of light. Look at this picture. So we can see two different images of this wood in the mirror. You can see here this image and that image. We can see two different part of wood in the mirror. So this upper half of the wood, log of wood is in the air, and some part of it is in water. So we can see the upper part of wood which is in the air. We can see its image.
Reflect.
We can see its reflection on water. Can you see the reflection in water?
Yes.
Yes. Is this the reflection?
Yes.
Then what is it? The other
Refraction.
other one is the wood which is immersed in water. So it is the second half or lower half of the wood which is immersed in water. So this lower half of the wood is immersed in water. On the other hand, this is the image of the upper half of the wood which is in the air. Which is, yes, we'll be doing activities based on reflection and refraction. Okay. Now look at this. So we have parallel rays striking this thing. So you can see this ray when it strikes, it is just bounces off. It just bounces off. Now it is bouncing off, so it is reflection. So when it goes through this object, but its direction changes, then it is refraction. When it goes through the object, but it is re-radiated, you can see it is absorbed. So some part of the ray will be absorbed, its intensity will be reduced. And in this case, you can see that it is just going through the edge of this object, not through the object. Then it is diffraction. But in both the cases, in the refraction and diffraction, we can see the bending of light. Here we have bending of light, and here also we have bending of light. But here this object is acting like an obstacle, and therefore light is bending. It is acting like an obstacle, so light is bending. But here in this particular case, again, it is acting like an obstacle only, but this ray is passing through the object and is bent.
Bent, so it's reflected.
So it is reflected. And in case of reflection, we see the bouncing.
Bounce back.
Bouncing of light, we do not see the light passing through the object, which light just bounces off when it strikes the object. So this is the difference between reflection and refraction. This is the basic difference. Next, you can see here, you have already learned in lower classes about this ray diagram, right?
Okay.
When a light ray strikes the mirror, that ray is called incident ray. And incident ray, the angle between the incident ray and the normal is called the angle of incidence, and the point at where it strikes is called the point of incidence. And then it is reflected.
But the surface should be smooth and well polished.
Yes, surface should be smooth and well polished for reflection. Yes. Otherwise, we'll have reflection, but it would be diffused one. Diffused reflection.
Will be diffused.
Yes. But if the surface is smooth, then it is reflection. One is regular reflection, other is diffused reflection. In case of diffused regular reflection, you can see that we have parallel beam of light striking the smooth surface. And all the reflected rays, they are also parallel to each other. When a parallel beam of light is incident on a smooth surface, the reflected rays are also parallel. This is called regular or specular reflection. For example, reflection of light by a plane mirror. But if we have rough surface, then in that case we have for different angle of incidence. See, in this case also laws of reflection are equally valid. But here we can see different angle of incidence. For different angle of incidence, we have different angle of reflection. Incident rays, all incident rays, you can see they are not parallel. They are striking at different angles, and we are getting a reflected angle of reflection, different angle of reflection.
But the surface is rough, then incident rays will fall down only.
Hmm.
So reflected ones will move their direction. Why
See,
incident?
but incident rays also, see the surface is so rough. You can see that all the incident rays initially they were parallel, but when they strike the surface at different angles. Now, because they strike the surface at different angles, so we have different angle of reflection. As in this particular case, we have this angle I and this angle R. You can find that here angle I is greater. If we look at this angle I, then this angle, let this angle be angle I2, and this has I1. So here we have I2, which I2 is greater than I1. We can see. And for this particular case, we have I2 is equal to R2. For this particular reflection, we have I1 is equal to R1. If you look at this reflection, then we have let this angle be I3. These angles are not equal, but pairs, the pairs which are forming here, you can see I3 and R3 are forming a pair. These two angles are equal. I3 is equal to R3, I2 is equal to R2, I1 is equal to R1. So when a parallel beam of incident parallel beam of light is incident on a rough surface, the reflected rays are scattered in all directions. This is known as irregular reflection. It is also called as diffused reflection. For example, reflection from the walls of the rooms, etc. And what is the importance of diffused reflection? We can see light even in the room, even inside the room where there is no sun. There is no sun. Even then we can see. We can see, right? That is because of diffused reflection. It is due to the irregular reflection that the object can be seen from all directions.
So it is important.
Yes, it is important also. And irregular reflection also follows the laws of reflection in the same way as regular reflection follows. You can see here that reflection of light, we had done this ray diagram earlier. This is the incident ray. This is normal. And incident ray is the ray which is incident on the mirror or strikes the interface. Yes. And the point where it strikes the surface is called the point of incidence. And at the point of incidence, we draw a normal. Yes. Normal is just the imaginary line. It does not actually exist. We draw it. When we draw this ray diagram, we draw it. Angle between normal and incident ray is called angle of incidence. In the same way, we can draw the angle of reflection. And this is the reflected ray, which bounces off. The ray which bounces off is the reflected ray. And the angle between normal and reflected ray is called angle of reflection.
Angle R.
Yes. So this is reflection. You can see that it is taking place in the same medium air. Incident ray and reflected ray both are in the same medium air. Now we have a second case. You can see the incident ray and some part of it is refracted. Some part of it is refracted, and this is the refracted ray. And this part of light is going in the water. Na? In the water, we can is going through the water. And this angle, the angle between the normal and the refracted ray is called the angle of refraction. And you can see that these two angles are not equal.
Yes.
We can see that this angle,
That is right.
light ray is bent and this angle appears smaller in measurement. If we measure the angle, we'll find this angle smaller. Light is bent when it passes through some other medium. This is refraction of light. So reflection of light is bouncing back of light on striking the surface in the same medium. On the other hand, refraction of light is bending of light when it passes from one medium to another.
Like through air.
From air to water. If it is in the same medium air, then it is reflection. But when it goes in the different medium, then it is reflection. Because then light bends. Okay. In case of reflection of light, speed of light, wavelength of light, frequency of light remain unchanged. There will be no change in the speed of light. It will remain the same. Wavelength of light will remain the same. Frequency of light remains the same. There will be no change in these components, in these quantities. But in refraction of light, we can find the change in speed and the wavelength of light, but there is no change in the frequency of light. Frequency remains the same, but speed and wavelength changes. How are these three quantities related? Is there any mathematical relation between speed, wavelength, and frequency?
Yes, they form different angles.
No, what is the relation? Velocity is equal to V is equal to nu lambda. Velocity is equal to frequency multiplied by wavelength. Okay, V is equal to nu lambda. In this case, in case of reflection, we have angle I and angle R always equal. Yes. And here, in case of refraction, I is not equal to R. So in this particular case, we can see that I is greater than R. And there is only one case when angle I is equal to angle R, and that's the case when light falls normally at the interface. So if a ray falls normally at the interface, it goes straight, undeviated, like this, air to water. It goes straight, undeviated. So in that particular case, we have both the angles equal to 0 degree. This is the only case in refraction of light where angle I is equal to angle R and the ray strikes the mirror normally. Normally. It goes straight, undeviated. If the ray is here, strikes the mirror normally, then that is the only case where the angles are equal. Otherwise, angles are unequal in refraction of light. While in case of reflection of light, every time we have angles equal. Okay. Now, in reflection of light, we'll cover the following topics. We'll start with the laws of reflection. Then we will do reflection of light by plane mirrors. We have the ray diagrams, which we'll draw. And then we have characteristics of image formed by plane mirrors. This we have read in lower classes also. And after this, we'll be doing spherical mirrors. Parts of spherical mirrors, and there are two types of spherical mirrors. Yes, concave and convex. Then we have position, nature, and size of image formed by spherical mirrors at different positions in front of the mirror.
From different size and
Yes, we get different sizes of the image. When we place the object at different positions in front of the mirrors, we get different sizes. And then we'll study uses of spherical mirrors. Where do we use convex mirror? Where do we use concave mirror? Then we have mirror formula. So this topic is important. 1 upon b plus 1 upon u is equal to 1 upon f is the mirror formula. And in exams, we get questions based on this, numerical problems based on this. Then we have sign convention, and at the end we have magnification. And the formula of magnification is this. H dash is the size of image, H is the size of object, V is the image distance, U is the object distance, F is the focal length of the lens or the mirror. Sorry, focal length of the mirror, not the lens. We are doing mirrors now. And then at the end, we'll be doing numerical problems and conceptual problems based on reflection of light. So these things we are going to cover in reflection of light only. This is one half of the chapter. It's a big chapter and it takes 1 month to complete the chapter. We need at least 12 to 15 classes to complete this chapter. So what is reflection of light? It is a bouncing back of light.
Now bouncing back of light in the same medium on striking the objects.
Yes, that's called reflection of light. So object that we see around us is due to reflection of light. Yes. Next we have ray diagram. This we had done in lower classes as well.
Yes.
How do we draw it? First we draw an draw a mirror first. Mirror and then incident ray.
Then incident ray and then reflected.
No. First we draw the mirror, then we draw the incident ray. And this is the point of incidence. We write this point as point of incidence, and at the point of incidence we draw a normal. Then we measure the angle of incidence. Now we need to keep these two angles same. If the angle of incidence is 45 degree, then angle of reflection has to be 45 degree only. Then if this is 45, it has to be 45 angle R. Then we draw another angle of 45 degree. And this ray is called the reflected ray. We write this ray as a reflected ray. This is how we draw this ray.
जब हम बोर्ड एग्जाम में होते हैं ड्रॉ करने के और हमने बिना मेजर करे ड्रॉ कर दिया तो उसकी मार्क्स कट हो
हाँ, वो मेजर कर सकते हैं. अभी आप करके दिखाओ. Do you have your pencil, eraser? Next, we have laws of reflection. So there are two laws of reflection. First law is that angle of incidence and angle of reflection, they are equal to each other. Angle I is equal to angle R. Okay. And second is incident ray, reflected ray, and normal. They all lie in the same plane. So these are the two laws of reflection. And what if the ray falls normally on the mirror?
the ray will reflect back
Along the same path. Along the same path.
like a ball.
Yes, the ray reflects back along the same path. It will retrace its path. The ray will retrace its path, and in this case, I and R both are equal to 0 degree. This is the only case where we have 0 degree angle, where incident ray, reflected ray, and normal, they all coincide with each other. All the three coincide with each other. Normal is the imaginary line, which does not exist actually. But we consider normal, right? So normal and incident ray and reflected ray, they are all coinciding. We draw it because we need to find the angle of incidence and angle of reflection. How will we find the angles? Therefore, we draw the normal. Reflection by plane mirror. We'll start in the next class.